Welcome to this lesson on isotopes. In this presentation, we will learn what isotopes are, how to interpret atomic symbols, why isotopes have the same chemical properties, and how to calculate the relative atomic mass. Before we dive into isotopes, let's quickly review the structure of atoms. Atoms are the smallest units of elements. They contain protons and neutrons in the nucleus, with electrons moving around the nucleus. The number of protons in the nucleus decides which element an atom belongs to. This is also known as the atomic number. Neutrons do not change the type of element, but they do increase the mass of the atom. The total number of protons and neutrons is called the mass number. Atomic symbols are written with the mass number at the top and the atomic number at the bottom. For example, carbon-12 has a mass number of 12 and an atomic number of 6. Now we can define isotopes. Isotopes are atoms of the same element that have the same number of protons, but different numbers of neutrons. For example, carbon has several isotopes. The first one is carbon-12. It has 6 protons and 6 neutrons. Alongside carbon-12, there are other isotopes. Carbon-13 has 6 protons and 7 neutrons. Carbon-14 has 6 protons and 8 neutrons. Now let's look at another example of isotopes. The first isotope of chlorine is chlorine-35. It has 17 protons and 18 neutrons. Alongside chlorine-35, there is another isotope. Chlorine-37 also has 17 protons, but it has 20 neutrons. This shows that isotopes of chlorine have the same number of protons but different numbers of neutrons. Even though isotopes have different numbers of neutrons, they always have the same number of protons. Because the number of protons is the same, the number of electrons is also the same in a neutral atom. Since isotopes have the same number of electrons, they also share the same electronic configuration. This means that isotopes of an element behave the same way in chemical reactions. Let's look at chlorine as an example. Chlorine-35 has 17 protons and 18 neutrons. Chlorine-37 has 17 protons and 20 neutrons. Both have the same electron arrangement, 2, 8, 7. Let's calculate the relative atomic mass of chlorine. Chlorine-35 has an abundance of 75%, and chlorine-37 has an abundance of 25%. To begin, we multiply the mass of each isotope by its abundance. 35 multiplied by 75 gives 2,625. 37 multiplied by 25 gives 925. Next, we add these two results together. 2,625 plus 925 equals 3,550. Finally, we divide 3,550 by 100. This gives 35.5. So, the relative atomic mass of chlorine is 35.5. Let's take a moment to test your understanding of what we've covered so far. Please choose the correct answers to the following questions. You can pause the video if you need more time and also re-watch to answer the questions. Thank you for learning with ACE students. If you found this lesson helpful, be sure to check out our playlist for more videos. Every video includes evaluation questions to help you test your understanding. Our content is perfect for homeschooling, Google Classrooms, or private tutoring. Don't forget to subscribe and click the notification bell so you never miss a new science lesson.